The hottest commodity in the world of computing right now is the GPU, or graphics processing unit. Made famous by gamers, these chips are now revolutionizing the world of AI because of their ability to execute massively parallel processing. But getting data to these GPUs can be quite a challenge, unless you've engineered a new superhighway for doing just that. Find out more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanaugh here. And folks, I am super excited to talk about some of the coolest technology that I've seen in quite some time. I remember way back in college, I wrote my thesis for both English and philosophy on the same writer, who was Edward Albee. And he wrote a play called The Zoo Story. And there was one line in that play that just jumped off the page at me, and I'll never forget it. He said, sometimes it is necessary to go a long distance out of the way in order to come back a short distance correctly. And I was like, wow, that's pretty cool. And then I start thinking in the context of data and information and files and moving things around. And goodness gracious, from the earliest days of DM radio, I recall asking people from companies like Informatica and IBM and SAP and all these various vendors back then. I was like, can you guys get a strategic view of what data is moving where at what time? And I was thinking mostly in the structured data world. Today, we're going to talk about unstructured data as well. I was thinking about structured data with all these ETL processes: extract, transform, load, extract, load, transform. And the answer was always, huh? Like, what are you talking about? And I'm thinking to myself, that's got to be tremendously inefficient. I mean, so many times you're moving massive amounts of data that you're not even going to use. You're only going to use 10% of that or 20% of that. So there's just all this extra effort. And anytime you move data in these traditional ways, there are potential for errors. You can have truncated files, it doesn't load properly, you get performance issues, all kinds of reasons. And you think today about how incredibly heterogeneous and topographically challenging information landscapes are with all these different systems, operating systems, file structures, cloud, on-prem, devices. It's just crazy, and it's extremely challenging. Well, the company we're going to talk to today, a couple different companies that work together, they have solved for this very problem. And the first time I learned about it, I was talking to the CEO, David Flynn, who's on with us today, along with Molly Presley, who does the Data Unchained podcast. And we also have Matthew Shackstead from Parallel Works, good Chicago boy like me. And I figured out they solved this problem. So the company is called Hammerspace, and then we have Parallel Works, and Hammerspace is the space from which magicians pull things like rabbits out of hats. So it's a very interesting concept. But basically, they came up with this structure for a what they call a global namespace to which you have access for everything in your environment. So there's an overlay that goes on all of your data sources. And now you've got this namespace where you can pull rabbits out of hats all day long and orchestrate your data. And when I heard that, I was like, wow, that is solving for so many performance challenges, so many annoying aspects, so much friction in the workplace when people are trying to do things, whether it's do analysis of videos or pictures, for example, or whether it's to train AI models. These folks at Hammerspace are training Llama 2, this giant large language model out of Meta. So I thought to myself, this is amazing. And I always love when companies solve huge, previously intractable problems in elegant ways, because it's just a game changer. And there's going to be so much time saving and such a boost to morale for organizations that embrace this new way of doing things. But with that introduction, let me bring in David Flynn of Hammerspace. So did I get it correct? Is that about what you guys are doing?
That is a very good description, and I like how you talked about it as a long-standing and tractable problem. That actually
Right.
was part of my pitch going back, is we're solving things that the industry has failed to solve for decades now.
Right. Well, for decades, and you think about this is the realization I had like 16 years ago. What happens with ETL and data warehousing? people figure out, hey, this is cool. I want to be able to analyze my data. Oh, let's get this data set in. Let's get that data set in. Now you have all these batch windows that are stacking up. Well, it used to be you could do them overnight. Then there were so many of them. Now you got to do it 24/7. So constantly you're moving data around. I even wrote an article about this on eWeek about data orchestration. Around and around and around it goes. Where it stops, nobody knows. It just keeps on going. And that's where I get that question about strategic views of things. Like you're probably moving the same data 2 or 3 times a week that you don't have to do. That data only needs to be there once a week, for example. And this
Mhm.
takes time, it takes effort, it takes licenses of the software to do things. And we we did a series a couple years ago, something like sunsetting applications and other fairy tales of the enterprise, because it's so difficult to kill an application once it's extant somewhere in the enterprise.
Yeah.
But I think you folks have the real potential to unwind this spaghetti mess of data movement and data orchestration in a very elegant way that improves productivity and it gets the morale high. No one likes to spend time waiting to get files and going, oh, where is this file? Why isn't it loaded
Nobody
yet?
wants to be a data janitor.
Oh, ouch.
And that's what I mean, that's what people are doing, janitorial work. It's a sin that the movement of unstructured data today is done so manually. It's, I mean, data
Yes.
is the very definition of digital, and yet it's crying out for digital transformation in how we map it and manage it across infrastructure. And yet those things are done piecemeal with, point narrow solutions that require expertise. And so I do think it's the manpower element that's the biggest savings.
Yeah. Yeah, and improving the morale, right? So that's one of my soapbox topics
Mhm,
is
mhm,
when so
mhm.
what hurts morale basically is when you feel like you're spinning your wheels, when you can't get things done, when people are demanding something of you. That's why data engineers or data janitors are pulling their hair out and wind up like guys like me because they have expectations put on them and they can't get the system to work fast enough. They can't get it to load
Or,
fast enough, to move around fast enough. That's really bad for business and morale, right, David?
or the fact that you just spent the last year and a year plus doing a data migration from some storage system to another. And what you have to look forward to is that in 2 more years, in 3 years, you're going to have to do the same thing again. And it's going to be just as painful, if not more, because it's more data.
That's a very interesting point, and you're reminding me of one of the funniest things that someone said on the show years ago. Said, in the IT world and the data world, we always think that just one more layer of abstraction can solve our problems. Well, in this case, it kind of can, I think. I mean, there are lots of details to be sorted out and lots of use cases to be understood, or to be hammered out, so to speak. But I think that this particular layer, because you've created this high-speed conduit for data movement, unstructured and structured, it's like a super highway for information that anyone can access from anywhere in that incredibly dynamic environment, right?
Well, you're quite right. You can think of this as the missing level of indirection that we have never successfully implemented between data and the storage storing it. And the reason we never implemented it isn't for lack of trying, it's because you had to add an extra layer that indirects the data. You had to proxy the data.
Hmm.
So the key to having been able to solve this is actually moving to an architecture where you separate the control plane and metadata from the data path. And that allows you to have metadata served by separate control plane and the data path remain as direct or even be made even more direct than it was before to
Wow.
keep the performance. So, the problem is we had control and data, metadata, and data combined. Splitting them now lets us add that indirection in a way that doesn't compromise your performance and scalability. It actually unlocks performance and scalability.
That's very interesting. And then, last, I'll throw it over to you and then we'll bring Matthew in here. But essentially, we had sort of a two-lane highway, and now we have a highway that can expand out in lanes as needed, right? Isn't that the idea? Is that it could be an 8 lane
Yeah.
or a 64 lane or 128 lane during rush hour, just
Well,
expand
I
it out.
the analogy I like to use is that we have been living running on traditional surface streets, regular roads with stoplights and stop signs. What has been missing is a highway system at all that gets rid of the stoplights, stop signs, and other things that slow it down. And here we're talking about protocols, and that's why part and parcel of this whole discussion is actually the implementation of the parallel NFS and hyperscale, which are fundamentally what lets us separate metadata control plane from data and the data path. So we needed a new highway system because we had been working with legacy roads that simply didn't facilitate this. It's like in a world of DNS, it's like if your DNS server had to proxy all of the traffic through just because it was the thing that could resolve the domain. That would not scale. Proxies suck. Well, the storage world, when you open the file foo, it had to proxy all of the access through to foo through that same means. So this is a very fundamental changing to the underlying plumbing or the underlying roadways. And that's why different class of thing from surface streets versus a superhighway system.
Yeah, that's very interesting. It's almost like now you can go up into the air and have any number of things moving at different heights, so they're not crossing over each other and
Mhm.
still getting to where they need to get.
Well,
That's very
it's not a coincidence. This is the same innovation that enabled software-defined networking, getting the control plane separate from the data path.
interesting. I had wondered
So
about that too. That's a very good piece of information because
yeah,
software-defined networking, it's dynamic in nature, right?
yeah.
As more requests are coming in, it's like, okay, let's scale out as need be, scale up, scale down kind of stuff,
That's because the
which
data can flow directly like it always has. The control plane is held separate and apart and able to overlay without killing your performance. You couldn't do that with storage, not through the legacy protocols. That's why this whole adding the abstraction layer, allowing data to be orchestratable, being able to aggregate many different storage systems under a single pane of glass, under a single namespace, that will never work using the older protocols. It requires the parallel file system architecture borrowed from the supercomputing world, but applied through standards NFS to make it possible that NAS can now have that scale, and that's what we call hyperscale NAS.
yeah, I love that stuff, and I love that analogy, and let's bring in, speaking of parallel processing, Matthew Shackstead, and Matthew from Parallel Works. I remember talking to David a few months ago, and he explained what they had done, and I had this epiphany. I said, wait a second. I remember going to an HPC conference in Austin, Texas in like 2009, and I'd been in the world of big data processing for about a decade. And I'm walking all around this huge floor and all these vendors and all this activity, and there's no overlap between the worlds of HPC and big data processing. I'm like, that's bonkers. Like, why don't you guys talk to each other? Clearly, you could learn something from each other. And I think it's because HPC is very academic, it's a lot of life sciences and stuff like that. And so, those universities are an ecosystem unto themselves, and education
Mhm.
as an industry is sort of unto itself. But goodness gracious, and then when when David told me that, I'm like, dude, you're the first one I've ever talked to in all these years who figured that out. Took a page out of HPC's playbook and implemented it in the data world. I was like, congratulations. So, Matthew, what are your thoughts
Yeah, I mean
about all of
that's
this?
yeah, I'm with Parallel Works. I'll give a little story, but you hit it exactly. I mean, HPC is, a legacy, fairly niche world. You go to these conferences, a lot of academia or organizations that can support teams of PhDs operating their own supercomputing class systems, and
Right.
it's been that way for a long time. What we've been seeing happen over the last few years, especially with AI and LLMs and all this different sorts of machine learning workloads going on, the same infrastructure tactics and experience from HPC are now being applied to these larger AI systems that are coming online now. And we're kind of in pilot world and beyond at this point.
Talking all about parallel processing and parallel data movement and compute and storage and abstracting away the utterly painful process of dealing with heterogeneous information architectures and landscapes and topographies. And oh my goodness gracious, who doesn't hate trying to find some file somewhere or get some or where is that gosh darn thing? What these folks have done, I think, is absolutely fascinating. The company is Hammer Space and their partner Parallel Works. We were just talking to Matthew Shackstead before the break here, and Matthew, I keep wrapping my mind around. how much efficiency is gained by being able to abstract out these different layers of complexity and enable people. Because let's face it, at the end of the day, if you're using software, you're looking at something, you're clicking buttons and typing on the keyboard. And the more you can see what's happening, the more you can envision how to improve things. And that's a big part of what you guys have done, right? And I've looked at some of your slides too, and you can see the workflows and the processes. And once that all becomes visible, and once you can abstract out the complexity of like when to compute and when to align with all the storage needs, like that just greases the track so people can get stuff done, right?
Yeah, I mean, I like to think of us actually as like the plumbers on the compute side,
Hmm.
where the end users that are building these workloads don't have to think about the specific implementation details of the hardware they're running on. And, you said there's heterogeneous resources everywhere, and these, organizations, computing environments are becoming more and more complex. So that's going to continue. Quantum will have a chat GPT moment at some point in the hopefully pretty near future. And, organizations are going to start staging those in the same way that you're seeing GPU clouds being stood up as well. And so the layers used to interact with all these things are different. The people that want to do the work and the researchers and innovators and people building these pipelines, they don't need to get into the weeds of how to like run this on the top performing neural inference chip, right? They just want to see, take my PyTorch model and go run it over here. And so
Right.
we're trying to basically solve that problem. And what is interesting is data is a fundamental challenge in all of these type of workloads, state of gravity, moving it around. There's kind of old ways to do it, which involve the practitioners having to change the way that they're thinking. They have to stage data up and down to different
Right.
places.
Right.
This is where Hammerspace is kind of the glue that holds a lot of these heterogeneous resources together. It allows you to make the same namespace available anywhere. And that's why we're partnering so strongly with them.
Yeah, that's very cool stuff. That's a good segue to
Yeah.
Molly Presley, who hosts the Data Unchained podcast. That's how I first found out about you folks. Yeah, I was actually on your show, and that was a lot of fun. And I love that it's the Data Unchained as opposed to unleashed, right? Like one of the inadequacies of language is you wind up using the same word again and again and then unleash the power of it. Okay, unleash is my data a dog now? No, it's been
Yeah, it's a bit
chained.
more visceral to be unchained, isn't it?
Yes, it's like, okay, I don't want to be chained. I don't think anyone wants to be chained up. But yeah, tell us about your thoughts and what gets you excited about.
Yeah, definitely. So if you think about the conversations that we're having on Data Unchained, it really ties to your conversation, Eric, of old IT and new IT. The premise of the podcast is if you could know what all the data is that you have, whether it's coming off of sensors or the edge or different data centers, different clouds, and put it to use by the intelligence that wants to use that. That could be a GPU, it could be a data engineer, it could be a genomics processing application. What are the things you could do if you could feed all of that data to the intelligence that wants to take advantage of it? And so we delve into how are we doing things historically? What are new technologies and new solutions? And then what are the outcomes that companies are accomplishing with it? And it just ties so well to this conversation of there's really two key technologies that help in automating this. Instead of opening a ticket with IT to move data, you want software to identify what is the data, move it quickly and efficiently, and only move the data that you need.
Right.
But once you move that data, um, if the application or the compute or the user can't connect to it, it's kind of all for naught. So you kind of need to be able to identify and move data, but the applications and workflow need to know where it is too. And it's kind of the holy grail of distributed workflows if you put these two technologies together. So it's super exciting to see the two coming together and have the opportunity for end customers to think about the art of possible with them.
Well, yeah, and you make a really good point here that there are these two planes. There's the data, that's the fuel that's used for applications, and every application needs data. Otherwise, what would it be doing? It's always processing something, whether it's structured or unstructured or whatever. So you got to get the data to the processor, and then to Matthew's point, orchestrating the compute side. I mean, that's I mean, that's probably as revolutionary as orchestrating the data side at scale to be able to dynamically manage those workflows. I mean, you figured it's kind of how the human brain works. A lot of these LLMs and trying to understand how they work has got me thinking about how my brain works and how we ingest information over time and persist information. And then you can trigger information by trying to figure out, now, where was that one thing I wanted to? And you kind of get stepping stones to it. But I keep thinking about that, and if you can optimize both of those realms, that's when you're hitting on all cylinders, right, Molly?
Yeah, absolutely. And then it's multiplicative because, or exponential really, that if it's just me saying, where was that one thing I wanted and how do I move it? That's a task. But if you have an organization or a bunch of compute nodes that don't even know what data was ever created, and you can also feed that the data that other users created and other applications that you don't even know existed, then that's where it becomes really powerful.
Yeah, that's very interesting too. So, from the Hammer Space perspective, you will overlay on whatever information source there is, right? And so these are it's not an API, I don't think, but it's a connection to that you've created to give access to this hyperscale conduit that grabs whatever it needs and moves it to wherever it needs to go. Is that about right?
Yeah, we call it metadata assimilation, which is kind of a cool sounding technology, and it is actually cool. Our customer and partner over at Meta said it's like magic, and the why he says that is they needed to become aware of a lot of data very quickly. And you usually think about the physical parameters of a data move or data copy across networks and say, okay, that's going to take days or weeks or months to accomplish that. With Hammerspace, it was seconds, milliseconds. It was in that realm. David will know exactly what it was. And all of a sudden, the data that existed in these different infrastructure silos was visible to the applications and researchers because it was just
Oh,
metadata that we were unifying. We weren't actually moving the
I
data.
see. I
And
get
so
it.
it's magical because all of a sudden you can see it. And then if you want to do something with it, that's all done through our metadata control plane and file system so that if the date file is moving or something else, it's you can't it's abstracted from the user so they can work with the data while it's in flight or moving or just leave it where it is and never move it at all.
That's very interesting. And I'm realizing now too, so through the metadata, that's basically what all these different endpoints can see now is all the metadata that's available. And obviously metadata is much smaller than the real data that you're moving, especially with movies
Exactly.
and audio files and things of that nature. But if I see where it is, then I can just go grab it and get it done. And that's basically what's happening, right? So, okay, I want to get these sets of files to be able to run this process. And it's like it sees, okay, they're over there, boom, bring it back in and do the processing, right?
Yeah, and just imagine the power. You were talking about data scientists and data engineers, even just for individual humans who are working with this data. They can now look at the metadata of this massive data set, not just the data set that's been provided to them, and
Interesting.
ask interesting questions about find me anything that meets these certain parameters or objectives.
See, that is so big in the data science world because being able to see all the possibilities, that's what gets the human brain kind of juicing and running on all cylinders is like being able to kind of play around. That's why I've always loved the discovery side of data science and data management, whether it's visualization or just being able to understand the topography, right? Like if you can, let's say you're trying to get across a city in a very little segment of time, if you can see from above where all the roads are, you can then walk your way all the way through. Whereas if you're stuck in a labyrinth, then you don't know. It's going to turn left. Oh, that's a dead end street. No, can I go to here, there, whatever? That's kind of what you're enabling, right? It's that strategic view of what's out there. And from a data science perspective, that is tremendously enabling, right, Molly?
Oh, absolutely. In fact, I'm married to a data scientist, and so of course he knows about Hammerspace and what we do. And he's like, "Man, I just imagine the power." He worked as a data scientist at Amazon for ages, and you think about the number of objects when you're dealing with prime delivery that they're dealing with. But he still was only allowed a discrete data set that he had access to, not Amazon Corporation.
Right.
And so, what you kind of just imagine the possibility of your Ford Motor and your data scientists can see the metadata of the data coming off the autonomous vehicles if they're granted the permission to do so, at the same time as they're seeing the research data of the manufacturing facility and pluck out the relevant data sets to do science. And it's a massive change in not just data access, but the kinds of insights you can derive.
Yeah, and David, I'll bring you back in. You know, when you know your options, you can make better decisions. If you feel like you're constrained to, you know, 3 possible options, that's just not
Mhm.
as exciting if there are like 30 or 50 or 1,000. But you have to be able to see them and kind of understand them, and that's why it's so important to have this metadata abstraction layer, right? Because it's fairly easy to align metadata. What do you think?
Well, absolutely. And especially when we have proliferated so many copies of the same thing, just getting
Oh,
global
right,
visibility to that. And then the fact that now that it
right.
lives within a single namespace means I don't have to continue the madness of
Wow,
creating more copies of the thing.
wow.
So yeah, you've hit the nail on the head. It's really about unifying the metadata from all of this distributed storage into one. And that allows you to have that global visibility, dedupe the whole thing,
Eesh.
uh, and
And
avoid avoid making copies in the future because now data
right.
movement happens from within.
Yeah. Oh, that is so cool. And what's the stat? I've heard terrible stats of like 5, 6 copies of data are just all over the place. And it's like, if you don't have that strategic view, you don't know that. Someone put a whole
That's
bunch of
right.
storage over here. Someone backed it up over there.
And it only does you so much good to catalog all of it and find where all the copies are if you're still having to use the same copy, to move it around. You're doomed. Your inventory of the stuff is antiquated the moment it's done. That's why having the data movement happen from behind the single pane of glass and having that single pane of glass be the unified catalog of all of the data everywhere. That's the very important concept here.
That's
Logical
also,
unification of physically distributed data.
wow. Logical unification of physically distributed data. That's very, very cool stuff. I'm going to throw a little curveball at you and see what you think about this. I've been thinking just recently about old IT versus new IT and what's the difference between these environments. And in one sense, I'm going to say old IT is imperative programming, new IT is
Mhm.
declarative programming. Would you agree with that?
Absolutely. Well, that is part and parcel to data orchestration, is that in a data orchestration world, it's through the declaration of service level objectives that you describe what the data needs from the physical infrastructure to exist. If you
Right.
think about it, data is the focal point. And yet, what we have managed has always been storage, and data was only indirectly,
That's funny.
managed by the selection of what storage to copy it into. That's the tail wagging the dog. But
That's
in a
funny.
world where data is orchestrated, you actually use metadata to describe, hey, this data needs to be super reliable. I need to have 5 nines. I need to have 10 nines. This data needs to be super performant, right? I need to have
Oh,
this many IOPS. And oh, this data needs to have sovereignty to these countries, right?
wow.
So you express in a declarative fashion the constraints about how the data is to be rendered onto the infrastructure. And then
Wow.
the orchestration system applies that. So I think you have nailed it on the head here. Modern IT, the new IT is declarative. Kubernetes is declarative. You say what those containers need, and it will determine where to instantiate and run them to have the right capabilities. So it's the exact same thing, whether you're orchestrating the containers, container orchestration, or whether you're orchestrating the data. It's a declarative model. That's the
Yeah.
big difference. Imperative versus declarative. You hit the nail on the head.
That's very cool. We got about a minute and a half left in this segment, so I'm going to throw another one over at you. You know, in the development world, a lot of folks keep talking about shift left.
Mm,
And basically, shift left really means go further upstream in the process and workflow and technology to solve a problem way upstream so it doesn't wind up going downstream.
that's right.
And,
Yeah.
you know, shift right is like, okay, let's focus on the business applications where people are actually using. We'll put some checks in there because we're going to talk about data governance, for example, but we're also going
Mhm.
to talk about optimizing the flow of information. And I remember when I talked to you the first time, you told me that you went out and grabbed a couple developers from the Linux kernel to work on this stuff. And I'm going to throw this out there for us to think about in the next segment. You can't shift any further left than getting
That's right.
into the operating
Well,
system.
this we have to talk about next because what we're really talking about here is functions of the operating system, process scheduling,
Right.
data supply. These are file systems and
Right.
virtual memory subsystem and process scheduler. But we're talking about doing that at the massive scale, parallel and heterogeneous across whole data centers. And so what we're really talking about here is the operating system or operating environment for the modern parallel heterogeneous world.